give this the big clave treatment. We'll look inside. We'll just zoom in on that just a wee bit. Greetings, programs. Atari here, you there, and if you like watching him, her, him, or her, then you'll probably dig this channel. So hit the subscribe button and click the bell notification icon so you don't miss anything. Now let's roll. Okay, I'm sitting here in terrible lighting because the sun's low in the sky, but I have to go to the thrift shop to get something for this project. So let's go inside. Okay, so we've got a small selection of decorative Christmas lights and a few other things, and haha, perfect! So, this is a pretty typical strand of multicolored Christmas lights, or holiday lights, or as our friends across the pond call them, fairy lights. And I kind of like that name a little bit better because it is less clunky than, it's less clunky and it's like religiously neutral or whatever. Anyway, pretty typical setup here, it seems. A slightly deformed prong on that plug, which I can fix and straighten up. It's not too big a deal as long as the innards are okay. Give this the big clave treatment. We'll look inside. We'll just zoom in on that just a wee bit. So inside we have a couple of fuses. These are 3 amp 125 volt fuses. And you can see there's 1 and 2 of them. And that's really it. There's no microcontroller. There is no nothing. Just 120 volts going into each one of the lights. Now, notice we have 2 wires going out, and then we have 2 wires going out to our first bulb, and then from each subsequent bulb we have 2 wires going to down the line. And then this one is the ground line. I should verify that it still works, huh? Okay, so now you see it is plugged in, and it does work. You know, back in the day, when I was a kid, we had these strings of lights, and if one of the bulbs burned out, or you removed a bulb, then the whole thing would go out. And that's because it was wired in series. And we can talk about series versus parallel in just a minute. But essentially, what modern light strands have done, and it's not like a big technological leap, it was just the manufacturing just got cheaper, so they were able to do it this way. Going into like the early 90s, they started manufacturing them with the light strands in parallel. And I'm trying to look in here to see. You can see the contacts there. You can see the contacts. And what happens is when you remove, so that's like, that sits in there like that. And what it does is it's got this bit on the end here, and that pushes these contacts apart, and it's able to connect to the actual light contacts on the inside. But when we do it this way, that's all spring-loaded essentially, and now that this little guy is out, those just spring back together, closes the circuit, and calls it a day. That is how you can pull a bulb out and it still works. But let me draw you a picture and we'll talk a little bit more about it that way. Oh, by the way, this video is part of a series documenting a project for Element 14 Presents. So check out the show notes down in the doobly-doo that'll take you over there. The electronics engineering community where you can connect and collaborate with top engineers from around the world. Do check it out and click on element14.com/presents, and I will see you over there. Okay, please excuse the crudity of this drawing. I didn't have time to paint it or build it to scale. Anyway, you got your plug right here. Positive, negative, alternating current, doesn't matter. You can flip-flop. As you can see, the plug is not polarized. So that part doesn't matter, just so long as one is going in one direction, one is going in the other. We're just fine and dandy. So we'll say the positive side, for argument's sake, goes out, and inside the bulb is basically this sort of a wiring arrangement. So you've got your contacts here, which you plug the bulb in, that contacts the bulb and causes it to light up. The current flows through it, causes it to light up and move on to the next bulb. However, if we remove this, then that just closes because it's spring-loaded. That closes and moves on to the next one. However, when a bulb blows out, this is the interesting little bit. This is sort of the, not a technological quantum leap advancement kind of thing. It's something that was entirely possible. It was just not economically feasible up until manufacturing in the 80s, going into the 90s, made it a little bit more feasible. What we have here is a little shunt. And basically, it is a resistor. It's a high-value resistor that, once this burns out, now we have some level of resistance, causes some material to burn off, and then the current flows through normally. Then it runs into the next one and the next one. So that's why we actually have two different wires going this way. So it's sort of like a series parallel arrangement. Where everything is wired in series. However, there is a parallel bypass for each of the bulbs in case they burn out. Now, that is not to say, again, that's a different mechanism from just removing a bulb and the rest of them stay on, just because that's how the little thing closes, and it's basically a switch at that point that just redirects it into the light, calls it a day. So that's basically how they're arranged. It's not super crazy complicated. Fairy lights are actually rather simple. So that's sort of that. So let's do a little bit of testing here, and we shall see, as well as we can, we'll see how this sort of works. Okay, so I've built a little sort of a test plug. Essentially, it is one of the light plugs. Pulled that out. I have just put in some bare wire just to connect to those contacts so that I can measure the voltage coming off of there. I expect it to be 120 volts, but you never know. Now, we are dealing with household current. We are dealing with 120 volts AC, 15 amps. Don't mess around with it if you don't know what you're doing. This is, I am a trained professional. I have shocked myself on household current I don't know how many times. It's not pleasant. It probably won't kill you, but, don't take my word for it. It is quite unpleasant, and it can stop your heart. So let me plug that in. Hold on to your butts. Ah, fancy. Lights are lit up, and 120 volts here. So now I reliably have 120 volts that I can siphon off of just about any of these standard light strands. So in the next bit, I am going to take this and use it to power something in the next video. So be sure to subscribe, watch that video when it comes out, and don't forget to click that bell notification icon so you don't miss anything. My name is Atari, and until next time, tally ho, y'all. Things around here too, video that you'll probably like, and something else, and subscribe, and oh, show notes. Show notes are over here. You can check those out on the Element 14 community at element14.com/